The first Meteosat was launched 45 years ago on November 23, 1977, beginning a program that has provided geostationary meteorological satellites ever since. Joining us today is Jochen Grandell, program scientist for the Meteosat third generation, to talk about this continuing project and its crucial weather data collection. Thank you, Jochen, and welcome.
Nice to be here.
So, tell us about Meteosat. Can you give us sort of a basic bottom tier description of what the program is and does?
Okay, so you already said we started 45 years ago, so that was the first generation. It was rather small satellite, but still that's what we started with. I have to start by explaining that, okay, there are two kinds of basic meteorological satellites, or let's say weather satellites. So the ones which are so-called geostationary
Mhm.
satellites, and then you have so then we have the polar orbiters. I will be just concentrating on the geostationary ones here. So they fly at around 36,000 kilometers. I think it's 22,000 miles for you, I guess. Um, and so they are quite different to the polar orbiters in how we use the data, how the data is collected, and what they are as actually kind of beasts. So the basic difference is that the geostationary looks at the same, stays over the same spot on Earth the entire time.
Mhm.
So it spins with the same rotation speed as the Earth does. So it's will stay focused for your area the entire time. You can see the changes which take place, let's say, rapidly, and you can continue to follow that 24/7. In a polar orbiter, you fly over it and you see it twice per day. So that's a
Okay.
kind of a snapshot only. So that's the basic difference in how you use the data. You from this you can already kind of gather that you for the from a gestationary you do look at rapidly moving things. That's your main focus, like thunderstorms or developing thunderstorms or let's say potential thunderstorms. You
Mhm.
will do observe those, and that is your main or primary objective of the mission. Um, you of course have secondary missions as well, like you have like your climate activities not forgotten here. You do collect a very long time series of its measurements. You said 45 years is a very long time series already. Of course, the instruments have changed along this time, so it's not exactly the same data all along, but we do try to, let's say, make sure that we have a continuous record of everything we can. And of course, any new measurement we put on top of that will then add to this climate record eventually,
Mhm.
because we do put a lot of emphasis on continuity, because we are talking about an operational mission. So we don't just try something and then toss it out the window again. The intention is that we actually keep it there for the next generation, and then next generation again. Maybe improve it, yes, but the idea is not to do an experiment or research kind of mission. That's the difference between operations and research.
Okay.
Um, so, for example, as an example of this is we have now for the third generation, we have several new missions. We have a lightning imager, which is going to be launched now together with the first of this third generation now in December this year. We don't have that in Europe so far, a lightning observation from space. On the American side, you have it on your latest generation, but we don't have it. So for us, it's new. But we start collecting this kind of data record now, and then we hopefully continue with that. So that's very useful to continue. Let's say very useful to see, for example, how the um, storm intensities change or storm, let's say, periodicity change over the time period. And we have in our field of view, we see, for example, we see Africa, which is extremely dense in, let's say, thunderstorms. So that is going to be very interesting for us. And and then we have also an infrared sounder coming up in a couple of years from now. Not on this satellite we are launching in December, but on the next one, and that is going to, let's say, provide us with different kind of data again that we then continue, let's say, monitoring for the years to come.
So, how many satellites do you have up at the moment?
We have geostationary satellites. We have four,
Okay.
and then we have two of the polar orbiters. We just decommissioned one of the polar orbiters just came to the end of life kind of scenario, so we had to decommission it. And I mean, eventually, they all have their lifetimes. I mean, they are very long lifetimes, all these satellites, because they are built for a long lifetime, as they are operational satellites. And as I stressed, I mean, this is not a research mission that goes on for a couple of years and then you have something else coming up. So, but that's why these programs take a long time, because you build for continuation of something which is already decades long.
Hmm.
And we started with the Meteosat second generation. The first one of that was launched in 2002. So that's now 20 years ago. And then, I mean, in the years to go, I mean, in between, we launched the three other ones, and they are still all in operation, so they are still working. It's been extraordinary long time. But no, sorry, the one was already, yeah, it's just recently decommissioned, but very recently one of them. But I mean, this is a very long time period for a satellite to be in operations. And for this one, we aim at something similar, uh, at least 10 years of operations for, I mean, per satellite.
You mentioned a launch coming up in December and a second launch. What are these two? Are they adding to the constellation, or are you losing satellites coming up soon?
Um, they are first adding to the constellation. So the first one that we are launching is this what we call MTG-I1. Okay, this means Imager One. So we have two different instrument, let's say, complements. So we have the imaging instruments, the regular imager, that is an improved version of what we have currently on our satellite, and
Hmm.
then we have the lightning imager that I just explained about. And then on the second satellite, we have then the what we call the sounders. So we have the infrared sounder and the UV vis sounder. So these are two completely different type of instruments, and that's why that's also why they are kind of conveniently on, let's say, different platforms. So this is now launched in mid December, the first one.
Hmm.
um, it's not immediately, let's say pushing out anything else, because we have to have a parallel operations phase where we compare to the previous satellites and what they observe, and make sure that they are, like, let's say, what we call a calibration validation phase, where we actually see that they are doing something that we expect them to do. A part of that is a parallel operations phase, not just for us to have a look at it, but also for our member states. We have 30 member states, and they have to all be, let's say, trained and being, let's say, given time to make this shift to the new generation. That's not a small task for the member states, because it's really quite a lot of new data they have to handle and let's say work with. It's like 50 times more if you just count the megabits, and
Hmm.
this is a tremendous amount of new things to absorb for them. So I think eventually we will then park this satellite in the operational position, and we will move another satellite slightly away, and then we will also move a satellite likely over the Indian Ocean. These are all decisions to be done still. I mean, this is more like, let's say, more like on the political level to be done, these decisions. But I mean, this
Right.
is the plan.
Where are the satellites that are currently in operation focused at the moment?
Well, we have two which are very close to the zero longitude,
Hmm.
and then we have one over the Indian Ocean. So the because our member states are all in Europe, so we have to be around the zero longitude,
Hmm.
and we have two of those close to each other. One doing what we call a full disk scan, so um, we image the entire, what we call a full disk, the thing that we see from space.
Hmm.
uh,
Okay.
and then another one is then doing what we call a rapid scan. So it just looks at one third of the disk, and makes kind of a more frequent update of that area.
And how is the data used? What is it used for? How is it disseminated? Does this go out to the general public at all, or is this primarily just used in-house at, say, for scientists in general?
Um, our primary use is our member states met services, so meteorological services or weather services. Um, that is a primary use. The data is available also for other users, like research, or even private individuals can download data. But I mean, this is the primary. use. And if we talk about geostationary data, this is in general to observe rapidly changing developments of, let's say, potential thunderstorms or anything else that could be changed and could be changing rapidly. So it is not so much used for numerical weather prediction. So, for
Hmm.
example, these are what we call modeling. They do provide input data for that as well, but that's not the primary mission of
Right.
a geostationary system. Um, so I would say that the kind of primary use is really the what we call no casting, or let's say very short range forecasting, where it provides an additional data source for the forecaster who does the kind of a daily 24/7 work in the forecasting office of, for the next 6 hours, 12 hours of, let's say, weather. And it does also provide inputs to what we call um, high resolution regional models. So the global models are a different thing, but the regional models are more like for shorter term developments, and for that the data is going to be useful as well. Especially the sounder data, I think, is going to be um, very exciting for those who work with these regional models. So they are really, these models are employed for these short-term activities. So it kind of
Hmm.
fits well together with the kind of observations we are getting here.
How do people access the data? Is there a fee? Do they have to go through an organization? You said
Uh,
anybody can kind of look at it. So,
we have a data archive that is accessible. The only thing that if you would use data for commercial purposes, there is a license fee to be paid, and I don't know the details of how that works. But I mean, our member states and the, let's say, what we call the big centers, they get the data directly,
mhm.
either through a satellite, let's say, reception, or also we also have a so-called terrestrial system to receive data. So there are several ways of getting the data, but the archive is, let's say, for everybody accessible.
How has some of the more climate change effects, uh, has that impacted what you guys are looking at, what the mission focus is?
Mm,
Especially, we've been experiencing more storms in Europe. There's been colder weather. There's been drier weather. How has that impacted your work situation?
yeah, that's a good question. I mean, I get that asked a lot, and I mean, in general, you cannot pinpoint that. Okay, that this storm could have been, let's say, okay, you could have detected it and forecasted, yes, but would it have made a difference to the lives lost, or let's say property damaged? This is in the long term, of course, to be seen. I mean, how much of an impact you do there, but we know from the measurements we have that this is definitely doable. We can
Mhm.
increase the, let's say, reliability of warnings given to, let's say, the general public. And this is, by the way, one of the very critical things of data like this, because a forecaster is a human being working in an office, and if he or she makes a warning, it's going to be a big thing. So it's a kind of a, you need a little bit of um, you need some background. First of all, you need your own, let's say, expertise. You need to understand your data, and you need to you have to rely on your data. You have to be able to, let's say, trust your data, and you have to get new data that fits for this purpose. And
Mhm.
I've been told that, for example, on the American side, they've been very happy to get this lightning data in their system to exactly give this kind of a last thing of additional information they might need to, let's say, just be able to issue a warning in good faith.
Right.
Because if you don't issue a warning and then something bad happens, I mean, of course, that's a disaster. And if you do issue warnings and nothing happens, I mean, nobody believes your warnings anymore. So it's a very difficult situation for a forecaster. So they need to be able to digest all that data and make the best of it. That's a difficult
I
situation.
In an idealized world, where you could have whatever you wanted involved in your satellite constellation, what would you add? What would you put in there? What would you request?
No, that's a very, very difficult question because we are just now launching this one, and it takes time to actually absorb all we have and to understand the data and work with our users that, okay, this we would maybe improve, this we would like to have a better resolution of this one, or we don't need this much resolution on that one. That's still to be seen. And
Mhm.
I remember when in 2002, when we launched the second generation, first of those satellites, it was a very big change, a very big delta to the first one, and it took quite some time for the professionals working with the data to actually really effectively use it. And I think that this is going to be the same for us now, because things don't change overnight. They have to be used to getting this new data. They have to be able to absorb it in their own just computer systems alone. It's going to be an issue. And then, of course, to train all the forecasters and other meteorologists and scientists to actually understand what is in the data, it's a big undertaking. So I think it would be rather bold now to say that, okay, I would like to have this on top of it. uh, I think this I'm not quite willing to do now.
So, with the two launches coming up, are there any future plans beyond that at the moment, or is that sort of the focus right now?
For me, this is the focus personally, because I,
Mhm,
I work on this geostationary program alone. But we have, similarly to the third generation of the Meteosat, we have a second generation of the polar system coming up in just a few years from now. I mean, their
mm.
first launch is around 24, 25. I don't remember exactly now, to be honest. But that's going to be also a massive game changer for that kind of data they provide, because they have improved instruments in all categories, plus some additional information on other new instruments they have. So for the modeling community especially, that's going to be a major step forward.
And do you have any personal plans at the moment, or just focusing on this next launch?
Uh, I um, I used to work on the lightning imager myself
Mm,
prior to becoming the program scientist. So that is kind of a special, that has a special place in my heart, and I'm really keen on seeing that data. Um, I don't know how how personal we're supposed to get in this interview, but I'm 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 of course worried about things outside of the space business, like all these wars going on in Europe and
mhm.
things like that. So I mean, this is puts things in perspective. I can be very excited about my satellites and my data. In the end, um, it feels kind of small compared to the rest of the things happening in the world.
That's definitely fair. We talk about that, those situations a lot here on Daily Space, so I
Mm,
we understand.
okay.
Well, Jochen, thank you so much for joining us today. This has been a delight, and I have learned a lot about satellites. So, thank you so
All
much
right.
for all of the valuable conversation, and we'll hope to have you back to talk about the new satellites once they're up and operational.
I'd be glad to.
All right,
All right.
great. Thank you.
Thank you.